Hello students, in the last video I have shown you how we can get pure alumina from bauxite. Now in this we are going to see how we can reduce the alumina, that is Al2O3, to get aluminium from it by electrolysis. So keep watching. This is the second part of the extraction of aluminium. Okay, so alumina, in the first process we have seen how we got alumina. Alumina is the pure form of aluminium oxide, that is Al2O3. Okay, now reduction of alumina will give reduction of alumina will give aluminium. Okay, now aluminium is highly electropositive metal, as we have seen in my previous video where I have shown various techniques used in getting a metal from the metal oxide. So there we have discussed this. Aluminium is a highly electropositive metal, so it has a very strong affinity for oxygen, and therefore reducing agents are not suitable. They cannot be used for reducing aluminium oxide to aluminium. So what is done if reducing agents are not able to reduce a metal oxide? The next technique used is electrometallurgy or electrolysis of the metal oxide. Now here the extraction of aluminium, the aluminium oxide, the extraction of aluminium from aluminium oxide, that is electrolytic process, is known as Hall-Herold's process, named after the scientist who contributed to this technique. Okay. Now what is the purpose? Any process, the purpose is always asked. So what is the purpose of the Hall-Herold's process? Is to get aluminium from alumina. What is alumina? Alumina is Al2O3. From aluminium is Al from Al2O3. So this is the purpose of Hall-Herold's process. Now the electrolytic cell. What is the electrolytic cell? A rectangular steel tank is taken, and then gas carbon lining is there on the inner walls of the tank, which will act as the cathode. Let us understand the Hall-Herold's process. Okay. So we have the rectangular steel tank here. You can see this rectangular steel tank. The inner lining, the black lining here is gas carbon, which will be connected to now the cathode, that is negative electrode. And then we have graphite rods here on the top, which will act as the carbon anode. These are the anodes. So let us go step by step. Anode is made up of graphite, I have just shown you, and the graphite rods are suspended from detachable crocodile clips. Now you can see here it is suspended because the anode will get finished, so we have to replace. So there are clips here, crocodile clips here on top. So the clips will be, the rod can be removed from the clip and you can put a new clip there. Okay, so this will enable easy replacement. Now graphite rods get consumed as they are oxidized or used up or burnt up as they react with oxygen produced in the thing. Carbon reacts with oxygen, C plus O2. CO is possible, also CO2 is possible. Okay, so 2CO, C plus O2 gives CO2. So we can get these products. So carbon gets burnt, it gets oxidized because it is combining with oxygen, used up because it will finish up and go as gas, the solid changes to gas, and then burnt up because it will burn, carbon and oxygen will burn, producing heat. So in other words, we can say they react with oxygen. So this is happening. So the anode rods need to be replaced here. So the rods suspended here need to be replaced. As they get finished up, you have to put fresh rods, right? And then the electrolyte is alumina mixed with cryolite and fluorspar. Two more electrolytes, the compounds are used here. The electrolytic mixture, a solution of aluminium oxide in molten cryolite, it is written here. Now let us see the electrolytic mixture. 1, 2, 3. 3 substances are used. Cryolite is sodium aluminum fluoride, Na3AlF6. This is cryolite. Okay, Na3AlF6. And fluorspar is calcium fluoride, CaF2. So these two substances are added along with alumina. Alumina is Al2O3. Why are they added? The addition of cryolite and fluorspar help in lowering the fusion point or fusion temperature. We know alumina has got a high melting point. So heating to such a high temperature is a difficult thing, and the temperature is so high that even the container will melt and evaporate. That is very high. So heating alumina to high temperature of 3000 and above degrees Celsius is not practical. So what we do is we add these two substances which do not take part in the reaction, but they help in lowering the fusion point. Okay, so the electrolyte will fuse at a low temperature. So what are the reactions possible? Na3AlF 6 sodium aluminium fluoride. So it will produce 3 Na plus and aluminium ion Al triple plus and 6 fluoride ion. So this will remain as ion in the electrolyte. Then CaF2 calcium fluoride, or otherwise called fluorspar, will produce Ca plus plus ions and 2 fluoride ions. Now alumina will produce 2 Al triple plus and 3 O minus minus. Now what you can see is sodium and calcium are more electropositive than aluminium. So these substances will not react. They are not going to react. They are only going to remain in solution. The reaction is only in alumina, okay, because alumina has lower electropositivity than the calcium and sodium. So let's see the reaction. At anode, what will be the reaction? The oxide ion minus minus O minus minus. Anode has deficiency of electrons. You have to understand this. Deficiency of electrons. Anode is connected to the positive terminal, so it is positive. O minus minus will give neutral oxygen atom plus 2 electrons. Okay. Now at the cathode, what is going? Cathode is negative. Okay, and in other words, it has excess of electrons. Excess of electrons. So what will come here? The positive ion, that is cation, Al triple plus will come here, and then what will happen? Anode has excess electrons, so it will take 3 electrons from here and then produce neutral aluminium atom. So this is what is produced. Now since the number of electrons transferred on both electrodes should be equal, what we can do is the first equation multiplied by 3, second equation multiplied by 2. So here what you get, 3 O minus minus oxide ions will give 3 nascent oxygen atoms plus 6 electrons, right? Here you multiply by 2, 2 Al triple plus 6 electrons will give 2 Al, that is Al2O3 has 2 aluminium atoms, 3 oxygen atoms. They are obtained as separate, right? Now these nascent oxygens will attack the graphite anode and it will produce carbon monoxide and carbon dioxide. And the cathode is the gas carbon lining. The reaction, the second reaction, this one is happening at the cathode. So aluminium gets deposited at the bottom of the electrode. Okay, so here we have steel tank under which you have the molten aluminium. There can be a tap fitted here, so through which aluminium can be taken out time to time. So this is how aluminium is obtained from alumina, pure alumina extraction. So if you check the Hall-Herold's process, the purpose is to get pure aluminium from alumina. So that is achieved. So students, I hope you understood how we can get aluminium from alumina, the purpose of the Hall-Herold's process, how it is achieved, what are the reactions taking place. If you have questions, please you may write in comments and you may ask for notes or worksheets. It can be sent to you by email. Thank you.